Here we're going to go through this exam paper, so if you haven't already tried it yourself, go away and try it yourself, and you'll find the model answers here. So first thing, iron chloride can be produced by the reaction shown in the equation. Calculate the maximum mass of iron chloride that's produced from 11.2 grams of iron, and it also gives you the atomic masses. It's worth 3 marks. Your answer's got to be in grams, and so it says maximum mass of iron chloride. We know the maximum mass, so another way of writing this could be the theoretical mass. So in theory, how much should we make? I've put the equation on the right to show you my working through this. First thing is put in what you know. So I've got 11.2 grams of iron, and I'm trying to work the mass of this out. So the steps for this are 1, work out the moles of what you know. So my moles of iron equals mass over mR, which is 11.2 over 56. So my moles equals 0.2. Next step is work out the ratio. Well, the ratio, I'm looking at these numbers. So from what I know to what I want, there's a ratio of 2 to 2, which is the same as ratio 1 to 1. Therefore, my moles of iron chloride is also 0.2. Finally, your last step is work out the mass of what you want. So my mass of iron chloride, which equals moles times mR. My moles are 0.2, and my mR is 56, add 3 lots of 35.5. So overall, my answer comes to 32.5 grams. Is this sensible? Well, if I start with 11 iron, I could, in theory, make this much iron chloride if I add quite a lot of chlorine. The next question, it says the actual mass of iron chloride produced was 24.3 grams. Calculate the percentage yield. It also says if you didn't get an answer for the bit above, assume the maximum theoretical mass is 28 grams. Well, we got 32.5 as our answer, but it's saying if you didn't get this, you can still do the next question. So again, I'm going to show you my working, and the first thing I'm going to do is I'm going to do the percentage yield and write out the formula. Is the actual yield over the theoretical yield times 100%. Therefore, it says actually what I made was 24.3, and I'm going to take their theoretical mass of 28.0 times by 100, and you'll get an answer of 86.8%. That's to 1 decimal place, which is enough for this. Next question asks for the percentage atom economy, and it's actually given you the equation. Key things to look at the equation are you're only doing it of the desired product, and it's the sum of all the reactants. It has shown me the reaction, some formula masses that are useful to me, and it says calculate the percentage atom economy for making copper sulfate. So therefore, making copper sulfate, my desired product is copper sulfate, which is this one. So let's just put the numbers into the equation now. My desired product in the relative formula mass of copper sulfate is 159.5 divided by the sum of all of them. So I've got in my reactants, I've got copper carbonate, which has a mass of this, and I've got sulfuric acid, which has a mass of this. So if I do those, times it by 100, do all of this, I should get my answer of 72%. Now, something to be aware of, if there was a big 2 here, okay, then instead of just doing 123.5, I would have to double it because it's all the reactants and there are 2 lots of the copper carbonate. Okay, so just something to be aware of. When you're doing the sum of all the reactants, you need to make sure you include that number there. The next question is a bit like the question on the first page. Show me a reaction. It says calculate the maximum mass, so the theoretical mass of aspirin that could be made from 2 grams of salicylic acid. So 2 grams of that. It's given me the relative formula masses to make it quite easy, so as long as I know the process. Well, I'm going to put in what I know. So I know I've got 2 grams of this, and this is what I want to work out. Step 1, the moles of what I know. So this is the moles of salicylic acid is mass divided by MR, which equals 0.014. Step 2, you look at the ratio. Well, I've got 1 molecule of salicylic acid and 1 molecule of aspirin, so the ratio is 1 to 1. Therefore, my moles of aspirin is the same. Final step, the mass of aspirin is moles times MR, which equals 0.014 times by the MR given is 180. And it gives you an answer of 2.6 grams. Is this answer realistic? Well, if I start with 2 grams of one reactant, then yeah, I could make 2.6 grams of the product. It's in the same ballpark. Final page of these practice exam questions. It says the student made 1.1 grams of aspirin from 2 grams of salicylic acid. So this is the actual yield. Calculate the percentage yield. Again, it says if you didn't get the answer to the first bit, it's given you an answer to use. Okay, so you can still answer this question even if you didn't do the other bit. My first step would always be write the equation. Percentage yield is actual over theoretical times by 100%. Go back to the equation, question, reread it. The student made 1.1 grams. So there's the actual, what they made, of aspirin, and the theoretical, it says assume it was 2.5. We got a different answer on the page before, but I'm just going to use their answer. Times it by 100% equals 44%. So if you would have used the previous answer for the theoretical yield, you'll get a different answer, but I've used the one that they've given me. Suggest one reason why the method does not give the maximum amount of aspirin. So why is it rare that we get 100% yield? Well, we'll often not get 100% yield for a few reasons. We may lose some product when we purify. There may be an unwanted reaction, an unwanted side reaction, which may make a different product, and the reaction may not have gone to completion. Out of these three, the most likely for this reaction actually would be we'd probably lose some product. Maybe some of the aspirin is still left in some of the beakers or equipment that we used. Let's try the next question. So I've got sodium azide, which is giving me the formula, and it says it decomposes, so this means it breaks up on heating to form sodium and nitrogen. So it's showing me the equation here. A typical airbag contains 130 grams of sodium azide. Calculate the mass of nitrogen that would be produced when you have this much sodium azide decomposing, and it's told me the relative atomic mass. So again, I'm going to put in what I know. So I know I had 130 grams of this, and I'm asked about the amount of nitrogen. Okay? So step 1, the moles of what you know. So the moles of sodium azide is the mass, which is 130 grams, divided by the MR. The MR is sodium, which is 23, add 3 lots of nitrogen, which is 14. So if you do this, the number of moles you will get is 2, so you will get 2 moles. Step 2 is the ratio. Now in this case, the ratio is not 1 to 1. Actually what we've got is we've got 2 sodium azides turning into 3 nitrogens. So the ratio is 2 to 3. And I know that the 2 on this side is equal to 2 moles. So I want to know what the 3 is going to be. So the way I'm going to do this, I'm going to find out what 1 is. So I'm going to do 2 divided by 2, which equals 1. And then I'm going to have to the other side, do the 1 times by the 3 and give me 3 moles. So in this case, you're timesing your moles here by 3 over 2 to get your answer. Okay? Basically, what this ratio is telling you, it's saying for every 2 moles of the reactant, you make 3 moles of the product. And it just so happens that I've got 2 moles of the reactant, and therefore I make 3 moles of the product. So my final step is my mass of nitrogen is moles times MR. Well, my moles are 3 and my MR is 14 times 2 because I've got 2 nitrogens. So it's 3 times 28, which equals 84 grams. Now, does this make sense? 84, sorry. Does this make sense? Well, if I start with 130 grams of a reactant and it breaks up, one is going to be less, so it's broken up, and one of the products is 84 grams, and the other product then must be the other part of that to make up 130. Final question. 1 gram of nitrogen has a volume of 0.86 litres, and it's at this room temperature and pressure. What volume of nitrogen would be produced from 130 grams of sodium azide? If you didn't get your answer, assume that the mass of nitrogen produced is 80. So again, if you didn't do the bit before, you can still use this number 80, whereas we know the actual answer is 84. So 1 gram of nitrogen is this many litres. Well, we don't have 1 gram of nitrogen, we've got 80 or 84. Okay, so all we would do is do 0.86 times by 80, because if I know 1 gram is this, well 80 grams is 80 times that, which equals 68.8 litres. There is another quite clever way to do this, but it's a lot more complicated, and I actually don't know some of the conversions for it. But we do know 1 mole of any gas, so in 1 mole of nitrogen at room temperature and pressure is always 24 decimeters cubed. Okay, well I've got 3 moles, so 3 moles of nitrogen gas is going to be 3 times that, which is 72 decimeters cubed. Okay, so I know this is my volume. Now, I don't know what the conversion is to decimeter cubed to litres, but that would have been another way to be able to get your answer. However, your answer wanted it in litres, so the much more simple way is just to use the information it gives you. I hope you found going through this past paper useful. Good luck.